Hi guys, welcome back to the workshop and welcome to any new viewers. Today what we're going to have a look at is sort of an introduction or an overview as regards batteries. Pretty much every machine these days, be it a ride-on lawnmower, small tractor, car, jeep, boat, motorcycle, they all have batteries to start their engines. So what we're going to look at is sort of an introduction type of video to them. This is a sort of very complicated area as regards battery design and operation, so we're not looking to get into too much detail in a short video. But anyway, just a broad overview of what they are, and at least get you to the point where you can ask the right question or look at your battery and determine what type of battery it is, capacity, voltage, etc., etc. So what I'm going to do now is going to break this video into 4 sections. First section will be what types of batteries there are. The second section will be deciphering the numbers on a battery as regards voltage, capacity, cold crank amps. Third section then will be how to test a battery. And the fourth and last section then will be how we charge a battery then after that. And then we'll close up with a few comments at the end. I'm going to stick in links down in the description below for 3 different videos that I came across myself when I started to look into this. The first one will be how a battery operates in a sort of an engine. The second video then will be the types of batteries there are. There's a guy there called the Battery Guy, and he goes into great detail on battery construction. And the third video then will be sort of more of a, an in-depth look at a guy who fixes a battery on the side of the street, replaces all the internal components if you want to know a little bit more detail about it. Okay, off we go. Now, when it comes to battery types construction, the first one we're going to deal with is sort of the traditional flooded lead acid battery. You can tell these very, very quickly because they'll generally have screw caps, 6 of them on top of the battery. And the reason that there's 6 of them is that generally batteries are broken down into 2.1 volt cells. And then obviously 6 by 2.1 volts gives us 12.6, which is just sort of your normal operating capacity for a brand new flooded lead acid battery. Now, the way each of the individual cells work is that there's lead plates inside, half them negative, half them positively charged. There's little separator plates in between those as well to stop them touching each other. And then it's flooded with a sulfuric and water mix. Generally speaking, I think it's 65% water and 35% sulfuric acid. And that provides the electrolyte or the transfer medium for one plate to transfer electrons to the other. Now, these are all starter batteries, and the objective of a starter battery is to provide a very, very high current output to engage the starter motor on an engine, but they're also designed to maintain quite a high state of charge themselves. Generally speaking, these batteries should only deplete to about 80% at most. If you go below that, what happens then is that the lead reacts with the sulfuric acid, and what you'll get then is a sulfation of the plates. That can be a soft sulfation, which disappears when you recharge the battery, and it's like little crystals. Or there's hard sulfation as well, and that hard sulfation doesn't disappear then when you recharge the battery. So what you can get then is a battery that will measure 12.6 volts output, but because some of the plates are damaged, you won't have the same capacity, and you won't probably have enough power to start the engine despite the battery sort of reading good. So we'll say from a battery perspective, there's 2 operating characteristics that you must have right. Number 1 is the voltage, which is sort of the pressure that it can deliver to a component. And the second then is the capacity, which is the volume of power or work that the battery can deliver. So back to this one anyway. Flooded lead acid battery, screw caps on top. There's 6 of them there. And what we'll do is we'll just take a look inside. This battery, I know it's not good. It wasn't a tractor. It measured 12 volts for me, or not far off it. And it still didn't have enough oomph to start the engine. So what we'll do now is we'll have a look inside and see what we can see. Obviously, sulfuric acid involved here, so gloves, eyewear, normal safety protection. I think sulfuric acid in the eye now would make for a bad day. I certainly don't want to be testing it. Right, what I have here then is a borescope, which is basically a camera on the end of a stick. Turn him on, and we need to turn our light on then. Right, have our light on. So what we'll do is I'll hold this up to the camera if I can without a glare. Should be tough enough. Right, and we'll have a look inside. So as we can see there, those plates are badly warped, badly damaged. They should be just lovely and neat, sandwiched together without any sort of distortion or damage to them. Again, you can see there's a bit of mess of plates going on in there. So that'll tell us there that this battery, whilst still measuring or giving us 12 point something volts or just under it, there's significant damage in there to that. So we'll send him off for recycling. Now, our next battery then would be the more modern version of a flooded lead acid battery. What this is a gel battery, and instead of having a liquid sulfuric acid and water mix, what you have is a gel between the plates. So effectively it's maintenance free because the gel doesn't evaporate the same as the liquid. It's more capable of dealing with vibration. It's maintenance free, so you don't need to be topping up the liquid. And as well as that, we'll say it should theoretically, and depending on the design of the battery, allow us more leeway as regards the cycling. So if we pull this down to 50%, it shouldn't damage as quickly as a flooded lead acid battery. So that's the gel batteries. So we'll stick him to the side. And then the last battery on the list here is, we'll zoom in again, non-spillable AGM maintenance free. Now what the AGM stands for there is absorbent glass matting, and similar enough to the gel battery, it's a non-liquid separation or a separator between the positive and the negative plates inside in the battery. Again, it's more forgiving as regards cycle damage or damage to the plates. They can also be wound much closer than a flooded lead acid battery and should come in a smaller form factor, but generally speaking they're slightly more expensive as well. And what you'll find with batteries is there's a trade-off there between the traditional flooded lead acid, which would be the cheapest and the biggest output, getting slightly more expensive into the gel types, and then more expensive again into the AGM. Obviously with sort of some advantages as you progress up through that power or that price range. The more expensive batteries then, or the most expensive batteries, will be the leisure type batteries, which are designed to be charged up to 100%, run down to 10%, back up to 100, down to 10, etc., on a continuous basis, and last longer than you could do that with a flooded lead acid battery. Now, the intro to this video, I just did a sort of a shot of each battery with a little information card next to it. And effectively speaking, we'll say there's three numbers on a battery which you must take notice of. The first one is voltage. The second one is capacity, which comes in an amp hour rating. And then the third component, which a lot of people haven't come across, is what's called a cold cranking amp capability, or CCA. Now, the first one, 12 volts. All of these batteries are 12 volts. This is from a rechargeable lamp. This one is from a lawnmower. This one is from a 1.8 or a petrol engine, I think. This one is from a 3-litre diesel engine, and this is from a 7.6-litre diesel tractor engine. So they're all 12 volts, okay? So that indicates the pressure available, but you'd have to ask then, you know, what's the difference between a 12-volt battery of this size and a 12-volt battery of this size? And the answer to that is capacity. Now, if we look at this battery here, we can see that this is the 12 volts, but it's a 7 amp hour battery. So that's the amount of power in the battery that we can pull out, or the amount of work that this battery is capable of. Okay, on the other end of the scale then, this is also a 12 volt battery, the big tractor one, but it's 170 amps. So obviously significantly more power in this, whilst delivering the electricity at the same pressure. The third component then, the CCA, the lamp battery obviously doesn't have a CCA rating because it doesn't start an engine, but we'll take the next one up, which is the lawnmower battery, and that has a 230 cold crank amp capability. So that means we can pull 200 amps out of that battery for a certain period of time. Now, if we take the fact that it's a 14 amp hour battery, and if we pull 230 amps out of it, okay, it's not going to last an hour anyway, and it's going to last a very short period of time. Okay, so 230 is the cold cranking amp capability of this battery, so that's how much amperage we can pull out of that. The next one up then is a 600 amp out of this petrol engine battery, going up to 750 cold cranking amps out of the diesel battery, or the diesel engine battery. And we're going up to a massive 1090 cold cranking amp capability out of the big tractor engine battery. So that dictates how quickly we can pull that power out. When you turn the key in any engine, it engages the starter motor, and the starter motor is a huge current draw. So, for example, a diesel Jeep, you know, a 3-litre engine can pull anywhere between 200 and 300 amps. And I don't know what the amperage draw on the tractor engine is, but I can imagine that to be up around 400 or 500 anyway. So if we're pulling 400 or 500 amp out of a battery like this, obviously it's not going to last very long. And what you'll find there is that, generally speaking, you'll get at most 3, 4, 5 minutes of turning the engine in any vehicle before the battery dies. That's because you're pulling the amperage out at such a high rate. Okay, so there are your 3 numbers as regards batteries. Now, as regards testing a battery, we have to test 2 of the components that we mentioned in the last section as regards voltage and capacity, or the capacity to do work. Now, thing to remember is that even though a battery might measure 12 volts, that does not automatically mean that the battery is good. So, for example, we'll stick him there so we can see him. Right, we'll measure this battery here, and we had a look in this, and we saw that there's significant damage to a lot of the plates. But notwithstanding that, that's giving us 11.47, so about 11.5 volts. So you'd say to yourself, that might just need a quick charge. In this particular instance, no. The plates are so damaged inside in that battery that it won't take a charge, and there's very little of the plates left attached to the whole integrity of the system. So this battery is a sort of a known good, and if we test him, we get 12.49 volts, which is ideal for what we want. Right, so if we got a voltage reading of 10 point something, 8 point something, 6 point something, etc., etc., what we'd established there is that we'd have a lost cell in the battery. If we pull out this battery now, which I know has been damaged, and we test them, what we'll do there, right, we've 4.78 volts measured on that. That indicates to us there that we've a number of damaged cells inside in that battery of the 6 cells that we started out with. And I did notice as well when I took this battery out, now whether you'll be able to see it or not is a different story, but this side here is pushed out, and you can see a sort of a deformation of the casing there. Anytime you see a deformation of any battery casing, that indicates that you've lost a number of cells because the plates have expanded and pushed out against each other and buckled, and it's that buckling that pushes them out. So that's where the gel batteries are better, because even if that battery did come out the side, or a plate come out the side of the battery, which is unlikely but still possible, the gel doesn't leak out all over the place and destroy an engine on you. So anyway, right, we've established that voltage is the first thing we test. If we have 12 volts or above, that indicates that there's 6 functioning cells, and our next test then is to find out how good those cells are functioning. As I said, if we let the battery run down in charge and leave it sit there for a while, what would happen then is the individual plates in each individual section would sulfate and the lead crystals would build up on those. If left for long enough in a state of discharge, those cells or those sections of the plates are irrecoverable. So what you'd find then is instead of having, and we'll say if we take the rating on this, this is a 105 amp hour battery. So you'd still measure 12 volts, but you might have only 50 of those amp hours capable to you because your plates are half damaged, or all of your plates are damaged to that level. So if we have our amp hour rating on the battery, that would also have our cold cranking amp capability from 750 down to 375, broadly speaking. Now, it doesn't operate as sort of in as linear a fashion as that, but you get the principle behind it that if your plates are only half the size or operating half as well as they used to, then obviously you're going to see a degradation in starting capability. So our next job then is to test that cold cranking amps and the capacity of the battery. To do that, there's a number of ways of doing it, and I'll stick up on screen there. There's an old style battery tester, which is called a carbon pile. And what that has is basically a big copper element in it. And that copper element creates a load, and that load then tries to pull out of the battery, and then you'll get a reading based on the capacity of the battery to deliver the load. The second type I'll stick up there is a more modern version. I don't know how they work exactly, but I think they measure the resistance on the battery plates or all of the battery plates, but it gives a reading for the cold cranking amp capability, the voltage, and the overall battery capacity. And then our third type of testing is actually to use the vehicle itself as the load that we need to put in the battery. Because it's all very well measuring voltage, but to find out whether the battery works, we need to stick a load on it and see does it deliver that load to us. Right, so what we'll do next is we'll go out to the Jeep, we'll stick on the digital multimeter on the battery terminals and see what the voltage falls to when we pull a load out of it. Now, the most common test I've seen with carbon pile testers and other testers is that the battery should maintain a voltage of 9.6 volts or above for 15 seconds at half the cold cranking amperage capability of the battery. So let's say this one here is 750. This should deliver us 15 seconds at 375 amp draw and still maintain a voltage pressure, effectively, of 9.6 volts or above. There's many, many different types of testing criteria for how a battery operates in temperatures, what temperature it should be at, what load it should be at, and how long you test it for. But from a homeowner's perspective, you have a pretty good battery if you can maintain the load exerted by the starter motor for 15 seconds without drawing or without dropping a voltage below 9.6 volts. Okay? Now we're stationed out here at the front of the Jeep. What I have is an electrical test meter. And what we'll do is we'll connect our probes onto the positive side. And if you have little alligator clips, they're very handy for these, or crocodile clips, depending on what you want to call them. Right, and what we're reading here is 12.59 volts, which is pretty good. And what we'll do now is we'll start the engine, and if you need to read the face of the meter, you might need a second person to hold it and see what it drops to as you turn the engine. There's also a possibility that your meter might have a min-max function on it. So if we press min-max, okay, what it'll do then is it'll record both maximum and minimum voltage that we get. Now what we'll do now is we'll read our max min. So 9.97 was the minimum voltage out of the battery when we put a load on it. and the 12.31 was what we started with. Okay, so that indicates then, and the 14.41, just in case you come up with a 14 volt reading somewhere, is when the engine starts, the alternator will kick out 14.5 volts there or thereabouts, and that's what runs the electrics in the vehicle. The battery, its main purpose is to provide starting power, but it also provides a dampening and a spike control, whereby if there's too big an electrical load on the alternator in the engine, that the battery will compensate that briefly, and then it'll start to recharge again then. So what it does is it sort of smooths out the flow of electricity from the alternator if there's too big a demand or too big a sudden demand put on it. So that's how we test using the vehicle itself. It's probably one of the most accurate tests that we have, because the vehicle itself is what the load of the battery is designed for or spec for. Okay. Now, when it comes to charging batteries, the first thing we must do is identify our battery type. The flooded lead acid batteries, the one we demonstrated earlier with the caps on top of it over there, and the sealed gel battery types, they're of a reasonably similar construction, and they can both be charged with a sort of a standard or an old style charger. Where you have to look out for is with AGM batteries, because of their particularly physical makeup. They require to be charged at a particular voltage and a particular rate, and what you actually need for them is a smart charger, which monitors the state of battery charge and will decrease the charging current appropriately. And then when they are actually full, it'll switch into a sort of a maintenance or a floating charge at that point. The one big enemy in charging batteries is overcharging them, and that creates heat. Heat then will gas off a battery, and in the case of a flooded lead acid battery, you can refill the chambers if you have to. With the sealed gel ones, you can't get into them or fill them up. So if you gas them off and you get rid of oxygen or hydrogen out of the electrolyte solution, you're sort of scuppered. And the same with AGM batteries as well. If they gas off and there is a little vent on these batteries despite them being sealed, and if they vent off their gases, you can't get those back into the electrolyte solution, which is a problem then. Now, we'll just demonstrate with this battery here. Now, a good rule of thumb or indication is that you can establish the state of charge of the battery by taking a voltage reading from it. On the sealed gel batteries, some of them, and I'm trying to catch it there now, there's a little sight glass there which should be showing green. And if that's green, that indicates a good state of charge. If it goes black, theoretically, then you should replace the battery. But one point to note is that little indicator is only connected to one cell on the battery. So you could have 5 good cells, one semi-all-right cell, and you're dictating the state of the entire battery on the semi-all-right cell. So just to be aware of that. As regards the state of charge of a battery, there are charts available there to tell you what your voltage reading indicates from the battery itself. And generally speaking, we'll say what it works out at is sort of 12.6 to 12.7 on a flooded battery, or a sealed gel battery is 100% charged. 12.4 would be about 75%, 12.2, 50%, 12 is 25%, and then 11.8 is sort of fully discharged. Anything under 11.8, then the battery's in trouble. So we'll just test this battery here now, and sometimes you need to scrape some of the surface dirt away, but you can get a good reading then. So this battery here is telling us it's 12.49. So that's well above 12.4, so that's indicating a state of charge of somewhere between 75 to 100%. So we don't really need to go charging that battery, but we'll just demonstrate how to charge a battery anyway. So we have our charger here, and you always ensure that the red positive goes onto the proper terminal. Stick him on. Stick him down here where we can see him. And we'll plug it in. Now, as you can see there, this battery is 75 or somewhere between 75 and 100% charge, but it's still drawing about 7 amps. As time goes by, that amperage draw will reduce down, and when it gets to 0 or close to 0, then you should disconnect the charger rather than overcharge the battery. So we'll leave that charge away there for a while, and we'll effectively sort of close up the video on this note. I found one other good video, and I'll stick in a 4th video, even though I said I had 3 in the initial introduction. There's a good video there as regards charging tables and stuff like that from a company called Delphi, who do a lot of car parts. So they're a good information source, as it were. If you have any questions, stick them in the comments down below, and until the next time, we'll see you.